Alright, so the denominator is simply the main unit of f prime. What about the numerator? How can we differentiate that function? Well, that's a complicated function. That's a composition of two functions. One function is this cosine inverse. Right? So the derivative of numerator is going to be derivative of cosine inverse of all that fraction, well, derivative of just cosine inverse, and by the chain rule it should be multiplied by the derivative of that fraction. Right, so that fraction has to be differentiated. Alright, well, let's look at what happens if we use this rule. Well, what happens if we compute these derivatives, well, pretend that we compute, and then substitute delta t equals 0? Will we come to anything interesting? Because, you see, the great thing about denominator is that we found this derivative to be something that doesn't even depend on delta t. So that is going to be a number. So this limit of a fraction is going to be a limit of a fraction where the denominator limits to a number. So the only question is, what would be the number for the numerator? Right? So it makes sense now to substitute delta t equals 0, and it's easy for denominator, it's just equal to that number. What happens if I substitute delta t equals 0 into the numerator? Will I have a number? Well, there is actually some problem here. Without even knowing what that second derivative is, what if I substitute delta t equals 0 into this fraction and evaluate derivative of cosine inverse at that point? So what would be the fraction when I substitute delta t equals 0? Well, that's what we computed already, right? When delta t equals 0, that fraction is equal to 1. So that means that I will have to evaluate the derivative of cosine inverse at 1. Right? Now, what's the derivative of cosine inverse at 1? Well, you can either remember a formula for the cosine inverse for the derivative, right? And if you remember it, it has something to do with this fraction, 1 over 1 minus x squared. And what you see immediately is that when you substitute 1 for the argument, because we are talking about the argument here, the whole argument being x. If you substitute x equals 1, you get infinity. So that's a problem. The problem is that if I compute derivative of cosine inverse of the numerator this straightforward way, I will end up having a product where the first thing becomes infinity when I substitute delta t equals 0. The second thing will probably be 0, but then I will have to do L'Hopital or something equivalent again.